When we compare 2024 to previous years, in particular the year prior, 2023, it was not an active hurricane season. It was relatively quiet. So we saw in 2023 Hurricane Franklin, Hurricane Idalia, the super powerful Hurricane Lee. All of those, fortunately, didn't do that much damage. Yeah, there was some wind damage and some flooding, but it wasn't as catastrophic as other hurricanes have been, like Hurricane Katrina, or ones that actually might make landfall at the Category 5 or 4 level. What's going on in 2024? What's caused it to be different than 2023? There are four key reasons that I'll explain here. First is something called the Saharan Air Layer, or the SAL. This is a particular area just off the coast of West Africa in which, because the Sahara Desert is here and the predominant pattern of wind is this general direction of east to west, what it does is it takes the dust from the Sahara Desert and it takes it over the Atlantic Ocean. It brings with it. And in the case of the summer of 2024, this Saharan air layer was much more noticeable, much more present, as we can see here in this satellite image that's just trying to pick up and identify where dust is located in our atmosphere. So once again, Africa right here, this is the Atlantic Ocean, the Caribbean Sea, Central America, and North America in the eastern part of the United States. There's Florida there. So this Saharan air layer is so thick, what it does is it does a good job of doing two things. First off, we think about dust in the atmosphere. What's that going to do? It's actually going to block incoming solar radiation. It's going to block that solar radiation from coming and actually reaching the surface. So as a result of that, the Saharan air layer is going to produce cooler temperatures at the surface. Essentially, that temperature is being cooled not so much by anything happening at the ocean, it's just the solar radiation is not making it to the surface in the same quantities because of that air layer acting as a protector, as a shield. Secondly, what that does, keeping in mind that hurricanes in particular, they need warm water. They need fuel. Further, that fuel, it needs to rise. And so if you can get that warm, moist air, that warm, moist water to essentially gain lift, the idea there is eventually it's going to cool, come back down, and form precipitation. So that's what we think of creating that instability, creating that stormy weather. Well, if we have the Saharan air layer acting like a lid, essentially it's going to prevent that convection, that uplift of that warm, moist air. And so here, this particular Saharan air layer does a good job of maintaining cooler temperatures at the surface, which thus removes that warm water, some of that warm water intensity. Even further, it acts as a lid in terms of holding back and preventing the quick convection that we would think of when we think about our powerful storms. Going back to our atmospheric lifting mechanisms from earlier in the semester, warm, moist air rises, eventually condenses and cools and falls back down as rain. If we can prevent that, or we can slow that process, of course, that's not going to happen in as much intensity, and we're not going to have as much storm activity. Even further, as I hope I showed throughout this semester, our hurricanes, doesn't matter if it even goes to the Hawaiian coast, doesn't matter if it goes to the Gulf of Mexico or the Atlantic Ocean, overwhelmingly, most of them originate off the upland area of the Ethiopian highlands. And so the predominant pattern is this east to west. And so here is showing the August 2024, essentially where the ITCZ is, the Intertropical Convergence Zone, that equatorial low pressure trough I mentioned earlier in the semester, this dense area of rain. And so essentially this is where we have storm activity, this high intensity of clusters of storms that eventually, if they get over the Atlantic Ocean, that's when, as I've showcased multiple times, that's when they can then get across the Atlantic Ocean, get across some warm water, intensify, and then really do a lot of damage as they become hurricanes, tropical storms, what have you. What this is showing is in August 2024, we have the current and the previous 10-day, and then the black is the normal, what we should expect. And so essentially what's happened in this summer 2024 period is the ITCZ has shifted up a little bit more north than it normally does. And even though, yeah, I get it, it's not that much farther north, even though it's not doing much, it's still going up to a little bit of a cooler latitude that is also, more importantly, a drier latitude. As we come up here, we're coming across the Saharan desert, subtropical high pressure that dominates. And so essentially as this dense rain band moves farther north, it's not becoming as intense because it doesn't have that warm, moist air helping to fuel it. Although it's still quite warm and moist. I'm not saying if you go there it's going to be super cold and dry like it is in Russia. It's still quite warm and muggy. However, this shifting of it just enough north is going to cause the storms not to be as intense because they're just a tad cooler and a tad drier than they otherwise would be. Our third key reason why 2024 was quieter than 2023 is the sea surface temperature. And this relates to the two factors I've already mentioned. The Saharan air layer, the dust that's helped to promote cooling at the surface, combined with these storm systems coming a little bit more northerly than they otherwise would, and thus not as intense. So on the left is 2023, and so I'm going to go back in time. So this is what I'm showing here is 2023 sea surface temperatures. Reds, of course, being warmer, oranges and yellows being warm but not as warm, and of course our coolest temperatures are those blues and greens. And we're not going to see huge differences, but once again these subtle differences, these subtle unique characteristics help to explain why 2024 was quieter than 2023. So now I'm going to do 2024, and we can already see, look over here, how we see more orange and yellow. So essentially what's going on here is 2024, we see cooler temperatures off the coast of Western Africa. And once again, hurricanes and these intense tropical storms and depressions and waves, they need warm water. And if the temperature of the sea surface is lower, it's not going to be as storm producing. Not saying it's not going to, but it's not comparatively being as much of a storm producer as we see here in 2023. And so going back and forth, 2024, 2023. Hopefully you see that. Now let's go to the key area here. This is the area where if storms get in this particular area and they get over that warm, dark red, maroon waters, that's when they can really get really intensified and become hurricanes and do all those things we've already talked about. So 2023 compared to 2024, you should see more maroon across the Caribbean Sea, Gulf of Mexico, and this part of the Atlantic Ocean than you do in 2024. So here we are trying to assess why 2024 was different than previous years. Our third key reason is the temperature of the Atlantic Ocean, Caribbean Sea, and those waters that we typically think as far as the origins and the fuelers of hurricanes were lower in 2024 compared to 2023. Our last key reason is a predominant or persistent wind shear pattern. Here we see August 14th, 2024, a very common pattern we saw throughout this particular hurricane season. And if I go up to a higher altitude, that's what I'm doing here, these upper level winds are doing a good job of blocking hurricane formation, helping them to not really come too far up, but more importantly, producing that thing called we talked about earlier, wind shear, differences in wind direction. So here, let's think of this path going up in this direction. At the same time, it's coming across winds coming from a different direction. And this common pattern that we see here during drought seasons in Indiana, and that's essentially what happens is a heat dome or a dome of high pressure forms over the Midwest. And what that does is it does a good job of bringing in warm and dry air from the interior, from Texas and Oklahoma. And so here, look at this wind that we're getting in Indiana. It's coming from Arizona, Texas, and it's producing quite dry air. So if you can recall, the September of 2024 in Indiana, extremely dry. But what that extremely dry condition was doing was also helping to keep hurricanes from really forming and developing and growing stronger as they start off as tropical waves, depressions,